Hello, and thank you for joining. My name is Amber Peterson. I'm a Research and Development Manager at MilliporeSigma based in St. Louis, Missouri. I would like to tell you about our evaluation of the ICON instrument from Advanced Instruments. The ICON aims to incorporate growth at the early stages of cell line development for faster and better scale-up decisions. Based on this tighter quantification and the confluence, cutoffs are applied for minimum titer and confluence values, and then the remaining values are used to calculate an ICON score, which can guide scale-up decisions. Addition of the growth data can enhance clone characterization at this high throughput plate-based stage, allowing the elimination of poor growers and earlier identification of high QP or specific productivity clones that might have otherwise been missed in favor of fast-growing low QP clones. What we found from the initial experiment is that the ICON score alone does identify unique pools relative to octet titer by itself and can eliminate poor growers from being scaled up. Here I'm showing the data from the top 50 mini pools ranked based on the octet titer. The octet titer and ICON titer are represented by black and blue bars respectively, and the ICON score for each of these mini pools is showed as a yellow circle. The inset in this figure shows the full distribution of ICON scores going up to values of 8,000. These are artificially high due to very low growth in some of these wells. This corresponds to what we would call a false positive, where the octet actually measured a high titer value, but the wells themselves have few or no cells. Now, this is not typical of the octet, but is an error that we see infrequently. In this case, the ICON allows us to identify those poor growers and eliminate them from our scale-up selection. Aside from these false positives, we can see that the octet and ICON titers correlate well. This means that 34 of the pools selected based on the ICON score would not have been scaled up if we were deciding based on the octet titer alone. After scale up, these pools were put into a 24 deep well fed batch assay, and we found that the ICON score can't accurately identify the top 25% of pools from the static assay. From this data set, we can see that the two highest QP clones identified were selected based on the ICON score and would not have been selected based on the octet titer alone. This data set also confirmed the strong correlation between an ICON titer and octet titer measurements, suggesting that discrepancies observed in experiments described earlier were largely limited to the relatively low titer values and related to octet errors occurring at that time. In summary, we find that ICON titers assay accurately measures titer based on good correlations with both octet and HPLC measurements. We saw that the ICON score can be used to successfully identify top performing pools and clones in a 7-day static assay for scale up, and that the use of the ICON score selects for clones that have normal growth profiles once scaled up. Benefits we see in this system are twofold. Firstly, growth data can help to eliminate poor growers early in CLD and avoid scale up of false positives. And secondly, the automated report generation for custom service projects and/or regulatory filings saves time and ensures that we maintain high quality. Thank you very much.